All right, so we're talking about graphing and identifying today. And the TEAC for today is pretty specific and it's pretty basic at the same time. And I think once we see what graphing looks like, I think we're going to feel much better. So we're just going to see as far as we can get. It is 9:01. We've got until 9:22. And like I said, if we don't finish, we don't finish. First thing we're going to talk about, we're going to identify some vocabulary terms. Roger, turn your game off, please. We're going to identify some vocabulary terms. And I know the font's not great. I'll improve that for the next time, but I think you can still read them. And so the way that it looks today, let me pull my Zoom screen up to make sure I can see what Miss Mills is seeing. Speaker view. All right. So, with that being said, we've got the word coordinate plane. Does anybody remember what a coordinate plane is from previous years? Steven?
Just like the graph that we got.
Absolutely. A coordinate plane is literally this right here. It's our graph. Now, obviously, if I wanted to get more specific, I could start drawing the lines for the x's, drawing the lines for the y's. But a coordinate plane is simply the four-part graph that we're going to graph all of our pieces on. It's not super important. You're not going to have a question that says, like, define a coordinate plane, but I want you to at least understand it when you see that word. Okay, I'm going to skip over x-intercept until I talk about y-intercept. The y-intercept is going to be where the line crosses the y-axis. And I think you know that already. I think you're very familiar with what a y-axis is. So if I was going to draw a line where the line crosses the y-axis, my y-axis is going to be that spot right there. Okay? We oftentimes call the y-axis the letter B. Remember we talked about the letter B previously. Slope equals, or y equals mx plus b. The b stands for our y-intercept. We're all feeling pretty good about y-intercept. Just give me a little head nod if you're good with that. Shake your head if not, and I can try to elaborate some more. Okay? All right. Well, let's take what we know about y-intercept and let's think about x-intercept. Does anybody want to take an educated guess on what an x-intercept is? What do you think, Hayden?
Where the line crosses the x-axis.
Absolutely. It is the exact same thing as the y-intercept. So everybody look right here. That's going to be our x-intercept. Now, I'm not going to write a definition for x-intercept because it means the same thing as the y-intercept, and therefore I think you can probably conclude that. I do, however, want to say this, though. The x-intercept is not nearly as important as the y-intercept, and so therefore it will not be questioned nearly as much, okay? But it is just good to understand what it is. I know in years past on the STAR test, they've actually had questions that said, what is the x-axis? You have a line just like this, and all you have to do is just literally mark x-intercept is 5. So I just want you to be aware of it. It will not be put into equations or things like that. But I do want to ask you this, though. Kind of brainstorming here. What does the x value always have to be on the y-axis? 0, right? When we have a y-axis, the x value is always 0. What do you think that the y value has to be on every x-axis? 0. So now you have been able to identify 2 points on every line. And if you have 2 points on every line, what can you do with 2 points? You can find the slope. And if you have the slope and a point, what equation can you put it into? Point slope form, which will then produce slope intercept form, giving you your y-intercept. Do we agree? Is that light too bright?
It's fine.
So, again, everything is coming back together. Everything is tying in together. That's the whole purpose of all of this. Zeros. I want you to circle the word 0. I want you to write a note that says, use later. Now, we won't use zeros during slope or linear equations, but we will use zeros for quadratics, which will come up later. But I'm going to go ahead and just introduce this topic to you. I'm just going to go ahead and tell you what the answer is. Zeros are just another form or another word for x-intercepts. Zeros are just another word for x-intercepts. zeros are another word for x-intercepts. Would anybody like to be bold and try to figure out why we call x-intercept zeros, Charger?
Because it's
Colin, what do you think?
Is the y value so much?
Yeah, because the y value is equal to 0. Now, don't get confused with that because we don't want to think about y-intercept as zeros, but the x-intercept is zeros. And I promise when we get to quadratics, it'll make perfect sense. We're just not there yet, but I just wanted to go ahead and introduce the word so that it's not a total shock when we get there. I feel like we're pretty good with slope. Can I skip over a definition on slope? Rise over run's the best I'm going to put for that. All right, moving right along to some graphing. That was the vocabulary portion of this. I'm going to grab a better marker moving forward. All right, so here we have some graphed lines. We have some graph lines. And before we start creating our own graphs, what I want to do is I want to talk about what do these graphs mean? What do they interpret? What can we tell from a graph already? What is just given to us? Addison, tell me one thing you notice about this particular graph.
It's positive.
It's positive. Can we agree with that? It starts low and gets bigger. Positive. Can you guys see pink on that contrast, or is it not enough contrast? It's fine. I'll get a darker one. What else do we know about that one? Somebody else. What else do you see? What else do you see?
y-intercept.
Okay, what is the y-intercept?
1.
Okay, so b equals 1. I'll use pink and blue for my mystery date tomorrow, since I don't know if it's going to be a boy or a girl. You know, we'll just, no? Okay, all right, cool. No. Charger, what do you think?
The x-intercept is -1.5.
Can we see right here? X-intercept is equal to a -1, 0. Great, that's awesome. Are we okay with that? What about the slope? Can anybody tell me what the slope is for this line? Bennett?
2 over 3.
We're going to go up 1, 2. I'll give him 2 there. 1, 2, 3. So m is equal to 2 over 3. We're all good with that? Let's be bold now. What's up, Katie? What do you notice? How we got the x-intercept? Do you agree this is the y-intercept because it crosses the y-axis? Well, this is the x-intercept because it crosses the x-axis right here. That's why. Can you put this in slope-intercept form for me? Hayden, you want to do it?
Slope-intercept y equals 2 over 3x plus b.
Come on, you can do better than that. Plus what?
1.
Plus 1. Boom. Slope-intercept form. You mean to tell me we were able to identify that much stuff without ever having to do a single bit of math? It's pretty remarkable. All right, let me throw you another curveball. Can anybody put this in point slope form? Okay, you want to give it a go?
So
Y minus 0, 2 over 3.
parentheses,
Okay, let's check it out. Okay, so based off of this, what order pair did she give me?
-1 over -1 x-intercept.
-1, 0, right? So what that means, and Katie, I'm not trying to put you on the spot here, I'm just literally teaching here, okay? If she did that correctly, that means that -1, 0 should be on this graph. Fair enough? Is -1, 0 on that line?
Yeah. No.
It's off slightly. She's very, very close. What would she need to change to make this perfect? She's there. She's like 98% correct. Katie, what do you think?
1.5.
Yeah, but if I come back and change this to 1.5, do we agree that she has the right of it?
Yes.
Okay? Do you see how the point doesn't matter? You can make whatever point you want it to be? Okay? Guys, that's a lot of information from one graph. Okay? Well, I'm not going to write it down for the next one, but positive or negative?
Negative.
Negative. Can anybody tell me what the y-intercept is? Carter?
3.
Give me a little more than that. Give me the order pair. Yes, that's fine. I'll take it. JT, tell me what the x-intercept is. 2, 0. Okay. Can anybody tell me what the slope is? Steven.
3 over 2.
You're so
No,
close.
negative 3 over 2.
Negative 3 over 2. Good, good. Negative 3 over 2. If I wanted to put it in slope-intercept form, can anybody tell me what that would be? Carter?
Y equals negative 3 over 2x plus 3.
Easy enough, right? Can I move past the second graph? All right. Zoe or JT, can you tell me how much time that video is at right now? It's at the very top.
It's like there's a
Yeah,
glare.
but there's like the glare right there.
Can't see. It says something like 20.
1042. Okay. I've given you a couple equations here. They're in slope-intercept form. And what I want to do now is I want to show you how to create the graphs. Remember yesterday's assignment, we were supposed to graph, and I told you not to worry about it? And that's where we're at. So now I want to show you how to graph these. Now y'all, I am not a fantastic artist. Please understand that. You are not a fantastic, well, some of you might be fantastic artists. You don't have graph paper. So we're going to just do our best on these graphs, okay? They don't need to be perfect. It's more the idea behind it. So what I want you to do is I want you to draw a coordinate plane. It doesn't have to be huge. I mean, I would say give you maybe like a quarter of your page. If you want to go bigger, feel free. But about a quarter of your page would be great. And what I want to do now is I'm going to teach you how to draw this graph. I'm going to teach you this. And then if we have time, I want to blow your mind with the calculator. I don't know if we'll have time today, though. Where should I start this line? Where should I start this line? Brian. Okay, so what number is my y-intercept? 4. So I'll go 1, 2, 3, 4. Is everybody okay with me having a point there at 0, 4? Now, is my slope positive or negative? Positive, which means that my line, side note over here, should look something like this when I'm done. Can we agree with that? This is the most important part of my lesson right here. So if you are sidetracked, if you're thinking about some drama with your boyfriend or your girlfriend, put it to the side for a second and give me your attention. From this point, I'm going to go up 2 from that point. So I'm going to go 5, 6, and then what am I going to do from here? Go over 1, 2, 3. Okay. Does everybody understand how I went from this point up 2 over 3? Everybody acknowledge that. So, let me just give you an idea here. Theoretically, with those 2 points, I have enough to draw my line. Is that fair?
Yeah.
If I wanted to draw a line through these 2 points, there's my line. But I want you to see this part as well. What if I want to find a spot over here? How would I figure out where my exact point would go? What do you think, JT?
You go down 2 and then back 3.
Do we agree? And what if I wanted to do it again? What would I do from this point right here? Down 2 over 3. So again, let's go. Down 2, 1, 2, 3. And if you notice, my line is still following that trajectory. If I continue doing this process, like let's say you're in detention and I was like, do it for an hour, and you kept drawing these lines, it's going to continue being the same pattern because slope is repeating. It is the constant. Okay, I'm going to pause this video and start my next one.